Day 57, the third practice sheet for minerals. You have taken the practice quiz by now, and you have seen whether or not you need to be doing this practice sheet. Please note that the format of this sheet is on the screen is different than your handout. I've made the font bigger and the margins more narrow so that I can fit it better on your screen. Question number 1, copy this sentence. A mineral's streak can be different from the color of the sample. So just rewrite this word for word. Hopefully your writing that sentence will help you to remember it for the quiz tomorrow. Number 2, we're actually going to see this happen now. Question number 2, rub the green mineral on the black tile. What is the streak? Go ahead and get your sample of the green mineral. It's called fluorite. Rub it on the black tile and you'll see what it is. I'll give you a hint. It's not going to be green. It's a different color than the color of the sample. Question number 3. Rub the bronze gold mineral on the white tile, and what's the streak? Again, it's not going to be bronze or gold colored. It's going to be one of the others. Go ahead and work that out now. If you need to get a sample, please ask your teacher. Number 4. Is the streak of a mineral always the same as the color of the whole sample? Please go ahead and circle your answer now. I hope that the previous 2 problems will give you the right answer. Number 4. Which phrase refers to a mineral with random rough surfaces with no flat sides? And the answer for that is going to be the fracture breaking pattern. That looks like a piece of gravel sitting on the side of the road. The cleavage breaking pattern is when you have a nice smooth surface when you break the mineral. Smooth, flat surfaces. Number 6. Which phrase refers to a mineral with smooth, flat surfaces and straight edges? Well, I hope you remember from just about 15 seconds ago when I said it's going to be the cleavage breaking pattern. The fracture, once again, is when it's rough and jagged like a piece of gravel. Number 7. What kind of breaking pattern does each mineral have? So we have mineral A here. I hope that you can tell from your photocopy that we have very nice smooth surfaces here, flat surfaces, nice straight edges. They do have corners, but between the corners it's nice and straight. And this is going to be the cleavage breaking pattern. Mineral B, unfortunately, is also numbered as 7. Is this cleavage or is it the fracture? From your photocopy photograph, I hope you can see that there are no flat surfaces. It's all jagged along the edges. It's like a piece of gravel, and so it's going to be a fracture grading pattern. Perhaps you can remember that fracture and gravel both have the RA in the middle, and so if it looks like a piece of gravel, it's fracture breaking patterns. Next one. Number 8. Mineral C. Again, this has no flat surfaces, no smooth surfaces. We have very jagged edges here. So will that make it cleavage or fracture? I hope that you circled fracture for that. Number 9, mineral D. We have very smooth, flat top. We have some straight edges, and then the sides are straight up and down, nice and flat. Is this cleavage or fracture? Go ahead and circle your answer. I'm not going to tell you what the answer is. When you are all done, and you will show me your paper and I'll check it off. Number 10, mineral E. Is this cleavage or fracture? Number 11, mineral F. Is this cleavage or fracture? You will check your answer when you are all done. Next, we have the equation density equals mass divided by volume. Would you please copy that once again off to the side here? Please copy the equation right next to where I have it typed for you. Now let's use that equation. Number 10, a mineral sample has a mass of 30 grams. The sample makes water in a graduated cylinder rise from 15 milliliters to 25 milliliters. What is the density of the sample? So the equation, once again, is mass on top, volume on the bottom, and right here is our mass, 30 grams. So that 30 is going to go on the top. The volume of the mineral is not 15. It is also not 25. This is the high level of the water when the mineral is in it. This 15 is the low level of the water when there is no mineral in the water. And so the volume of the mineral is the difference between these two water levels. The high minus the low is 10 milliliters. So you divide this with your calculator if you want, and you get the answer that the density is 3. So the grams always goes on top, and the difference of the water levels goes on the bottom. Number 11, a mineral sample has a mass of 80 grams. The sample makes water in a graduated cylinder rise from 50 milliliters to 70 milliliters. What is the density of the sample? So we write down our fraction. The mass goes on top. And then the difference of the two water levels goes on the bottom. So 80 divided by 20 is a density of 4. Number 12, do this one on your own. A mineral sample has a mass of 50 grams. The sample makes water in a graduated cylinder rise from 30 milliliters to 40 milliliters. What is the density of the sample? Go ahead and work that one out, and then we'll check it when you are all done. Number 13, copy this sentence. Just copy it word for word, please. Number 14, just copy this one. Number 15, metallic luster is when it looks like it is made with shiny silver or gold. Just copy that, please. Number 16, circle the minerals with metallic luster. So You're going to have 6 samples available to you. Please look at them, see which ones have metallic luster, which means that they either look like they are a solid chunk of shiny metal, or they have tiny little specks of shiny metal in them, specks of silver or specks of gold. If it's any of those, then it's metallic luster. If it looks like it's glass or just a hunk of rock, if it looks like it's marble or a crystal jewel, then it is non-metallic and you will not circle it here. Number 17, if a mineral breaks into smaller pieces that have smooth sides, what breaking pattern does it have? We've covered this question earlier in the video. Please circle your answer and see if you have the right one when we check your paper at the end. Same thing with number 18. If a mineral breaks into smaller pieces that are all rough and random, like gravel, what breaking pattern does it have? We've done this problem before. See if you can remember it. Circle your answer. We'll check it at the end. Number 19. When 2 things rub together, which one gets scratched? The softer material is going to be the one that gets scratched. We're going to use that idea in the next few problems. We have here a chart. And the hardness level goes from 1 to 10. I want you to write the word softest at the number 1 level. And then going down to the bottom of the chart, where the scale goes to 10, I want you to write hardest. The hardest minerals have a rating of 10, things like diamonds, for instance. Number 20. A mineral can be scratched by everything: a fingernail, penny, glass, and steel nail. How hard is the mineral? These numbers are the hardnesses according to the chart that we just drew on. And so if a fingernail can scratch it, that means that it is softer than the fingernail. Those are going to be numbers less than 2.5, numbers 1 and 2, and so on. So the answer to number 20 is A, less than 2.5. Since a fingernail can scratch it, it's got to be softer or a smaller number than the fingernail's 2.5. Number 21. A mineral cannot be scratched by a penny, but it can be scratched by glass. How hard is the mineral? Well, these are the 2 numbers that are important. If it can be scratched by one but not the other, then the mineral is going to be somewhere in between those 2 values. So it's going to be between 3.5 and 5.5. Number 22. A mineral cannot be scratched by a steel nail. How hard is it? Well, if it cannot be scratched by the nail, then it is not softer than the nail. It's harder than the nail. So harder means a greater number. Option E is the right answer for number 22. Number 23. A mineral cannot be scratched by a penny, but it can be scratched by glass. How hard is the mineral? Try to do this one on your own. Number 24. What is the formula for density? We covered this a few minutes ago in the video. Density is equal to, what's the equation? Write the thing on top and the thing on the bottom. Number 25. A mineral has a sample of 40 grams. The sample makes water in a graduated cylinder rise from 55 to 75 milliliters. What is the density of the sample? So we have the mass on top, and then the volume of the mineral goes on the bottom. The volume of the mineral is the difference of these 2 water levels. The difference here is 20. So that goes on the bottom. 20 divided by 40 is a density of 2. Number 26. Try to do this one on your own. A mineral sample has a mass of 20 grams. The sample makes water in a graduated cylinder rise from 30 milliliters all the way up to 35 milliliters. What is the density? Work out that problem on your own. We'll check it at the end. Number 27. A mineral sample has a mass of 100 grams. The sample makes water in the graduated cylinder rise from 50 to 75. What is the density? The mass goes on the top, and the difference of the two water levels, the difference here is 25. That goes on the bottom. Go ahead and divide that out and get the answer. Number 28. A mineral cannot be scratched by glass, but it can be scratched by a steel nail. How hard is it? Remember, you're given the hardness of something that cannot scratch, and the hardness of something that can scratch. So with those two numbers, what's the answer? We've done problems like this in the video already. Do number 29 as well. When you're all done, we'll check your answer. Number 30. It can be scratched by glass, but not by a penny. How hard is it? We're given two hardnesses. One does work, the other one does not work. So the hardness is going to be between these two. The next set of problems goes over some problems that people got a lot wrong on the practice test. So let's read through this first. A mineralogist, Gail Ina, took a mineral sample from Starved Rock State Park in Utica, Illinois. In her lab, she described the pink sample as looking like clear colored glass. When she rubbed the sample against a tile, it left a red line on the tile. According to her triple beam balance, the sample massed 20 grams. The sample made clear water in a graduated cylinder rise from the 25 milliliter level to 35 milliliter level. When she tried to scratch the sample, it scratched a copper penny, however it did not scratch glass. Finally, when she broke the sample apart, it always broke into an octahedral shape with smooth surfaces. Okay, with all that information, we can answer these questions. Number 31, what is the color of the material? Looking back at the reading, it said that she described the pink sample. So the sample color is pink. Number 32, what is the streak of the mineral? Well, when she rubbed it against tile, it left a red line. So this is the streak. Rubbing against tile, what kind of a line does it leave? Number 32, red. What is the luster of the mineral? It is metallic if it looks like it's made out of a solid hunk of shiny metal, or if there are tiny speckles of silver or gold in it. Well, in the story problem here, it says it looks like clear colored glass. So that doesn't say anything about speckles of silver or gold. And if it's clear, it's definitely not like a hunk of shiny metal. And so this is non-metallic. Number 34, what is the breaking pattern of the mineral? It says here that when she broke the sample apart, it always broke into a shape with smooth surfaces. Since it has smooth surfaces, it is going to be cleavage. It would be fracture if it was rough and jagged and random and looking like a piece of gravel. Next, number 35, what is the hardness Well, it talks about a copper penny and glass. One works, one doesn't, and so it's got to be between the hardnesses of these two materials. Looking at the chart, the hardness of glass is 5.5 and the penny is 3.5. So it has to be somewhere in between those two numbers. We don't know exactly what at this moment. We'd need more equipment to figure that out. And lastly, what is the density of the material? So, in the story problem, it says that the mass was, where is it? There it is, 20 grams. So that goes on the top of the fraction. I'm going to write it over here. 20 grams on top. And then the volume that's on the bottom is the difference of the two water levels. One of the water levels is 25 and the other is 35. So the difference of those water levels is 10. And we do our division, and so the density has got to be 2. Please show your all your work to your teacher, or the teacher might have an answer key for you to look at and to confirm that you have the right answers. Next we have notes on rocks. That will be a separate video.